Hi everyone, welcome back to our advanced cybersecurity series. Today we are diving deep into blockchain and cybersecurity. We'll explore how blockchain works, where it fits in security and real-world use cases. Whether you are a student or a professor or just curious, this video will give you a complete understanding. Let's get started. So our first slide is Introduction to Blockchain in Cybersecurity. First things first, what is blockchain? It is a distributed database that maintains a continuous growing list to order recorded called blocks. Because it is a decentralized, it does not rely on central authority, making it much more secure than traditional systems. This is where cybersecurity and blockchain interact. Both aim to preserve data integrity and prevent unauthorized access. So there's the introduction part. What is blockchain? How this decentralization improve trust and security? Relevance to cybersecurity practices. So our so we move to next slide. That is understanding blockchain technology. Let's break it down. Blockchain is built on distributed ledger technology or DLT. It is a network of nodes, each maintaining a copy of ledger. Each block stores a batch of valid transactions and it's linked to the previous one. Hence the chain. Public blockchains are open to everyone while private ones restricted access in cybersecurity. The consensus mechanism and cyber cryptographic foundation of blockchains are key assets. So these are the few understanding blockchain technology are distributed ledger technology, DLT, blockchains, nodes, consequence, public versus private blockchain. So we move to our next slide, that is cybersecurity threat landscape today. Now, why do you even need blockchain in cybersecurity? Cyber attacks are more frequent and complex than ever. Ransom phishing, DDoS attacks, centralized systems can become single point of failure. Once benched, an attacker has full control. Blockchain brings decentralization and transparency, which helps to migrate this. Rising ransom, phishing, and DDoS attack centralized systems and their vulnerability. Need for new secure architecture. So we move to our next slide, that is benefits of blockchain for cybersecurity. Blockchain provides some serious benefits. Immutability means data can't be tampered with. Decentralization reduces single point of failure. Every transaction is trackable and auditable. This feature makes it deal with for building trustworthy digital infrastructure. Data integrity and immutability reduce risk of single point of failure, auditability, and transparency. So we move to our next slide, that is use case in cybersecurity. So where is a blockchain actually being used in cybersecurity? Some major areas are identity and access management, securing DNS, distributed authentication system, ensure the integrity of software update. We will go into some other these in the depth. So first is identity and access management, secure DNS and domain management, decentralized storage and authentication. So we move to our next slide, that is blockchain for identity verification. Traditional identity systems are valuable to theft. Blockchain-based identities use a decentralized model. Users own their data can share only what's necessary. For example, with zero knowledge proofs, someone can prove that are over 18 without relieving their birthday. It is a privacy-first security. So in this blockchain for identity verification, first is decentralized digital identities. Second is reduce identity theft risk. Third is zero knowledge, proof and privacy. So we move to our next slide, that is blockchain in secure transaction. Contracts are another powerful tool. They execute automatically when conditions are met. No human interference. Used in financial system. They prevent fraud and ensure data accuracy. This is a game changing for sectors like fintech, supply chain, and even insurance. So, in a smart contract for automated enforcement, tamper-proof locks and records used in banking and financial security. So, you move to our next slide, that is challenges and risks of blockchain. So now let's be realistic. Blockchain isn't perfect. Some challenges included scalability. Blockchains can be slow for large-scale apps. Energy use. Proof of work chain like Bitcoin consume massive energy. Regulation. Governments are still trying to figure out how do how to regulate blockchain apps. So scalability issue, energy consumption, proof of work models, regulatory uncertainty. So we move to our next slide, that is blockchain and privacy. Transparency is a double-edged sword. While blockchain ensures no tampering, it also means data is visible to all in public chain. To handle this, permissions blockchains and zero-knowledge cryptography can be used. This ensures compliance with privacy law like GDPR, transparency versus confidentiality, private and permissions chain, GDPR and data compliance issue. So we move to our next slide, that is blockchain in incident response. So after a breach, Ben's incident response relies on logs. But what if those logs are altered? Blockchain makes logs immutable and time-stamped. It also allows decentralized alert system, ensuring them that even if one node is compromised, the alert reaches other. This builds resilience. So immutable logs for forensic analysis, real-time alert validation, decentralized alert system. So we move to our next slide, that is combining blockchain with AI. Blockchain and AI together for a powerful defense. AI detect threat using pattern while blockchain ensure data integrity. Today they can automate self-defense system like AI trigger a smart contract to lock account if a bench is detected. So in enhanced threat intelligence sharing, AI-driven smart contract for self-defense, Sigency for decentralized logic and machine learning. So we move to our next slide, that is case studies and real world adoption. Let's talk real world. Estonia uses blockchain to secure government records. IBM uses it to detect fraud in logistics and supply chain. Healthcare uses it to ensure the authenticity of medical record and track drugs. These are the just ideas, they are in the action today. Guard time, Estonia e-government, IBM blockchain for fraud detection, healthcare and supply chain use case. So we move to our next slide, that is implementing blockchain in security strategy. If you are an organization waiting to adopt blockchain, start with a risk assessment, choose between public and private chain based on your needs. Start small, perhaps identity verification, and scale from there. Also ensure staff and train in blockchain principle pilot project, and risk assessment, choosing between public and private chain, best practices, and vendor selection. So we move to our next slide, that is conclusion and future trend. In conclusion, blockchain is the transformative tools in cybersecurity. It helps secure data, reduce fraud, and increase trust. But it is not a silver bullet. It must be used wisely alongside traditional system and human oversight. the future of hybrid AI blockchain and cybersecurity working together. So decentralization is the key of future security. Blockchain will complement, not reduce traditional system, continue research and evolution ahead. So thanks for watching this deep dive for blockchain on cybersecurity. If you are found it useful, give us like, subscribe, and share your network. Comment below you through any question, and don't forget to check out our full cyber